everyone, in this video we are unlocking the world of functions, one of the most important concepts in all of mathematics. We'll break down what functions really are, how to combine them using composition, and how to reverse them with inverse function. Firstly, I am Kaushik, currently pursuing my studies in Sri Venkateswara College of Engineering. So, what exactly a function? A function is a special relationship that maps an input to exactly one output. Think of it like a machine. If you put something in, the machine processes it and you get something out of it. This is written as f of x, where f is a name of a function and x is an input. Let's say f of x is equal to x square. This means if you put input as 2, we get it 4, and if you put input as minus 3, we get 9. It always gives you one and only one output for each input. Now, two important terms we must understand with functions are domain and range. The domain of a function is a set of all inputs we are allowed to use. For example, if we have a square root function like f of x is equal to root x, then we can't use negative numbers as input because we can't take the square root of negative in real numbers. So the domain here is x is always greater than or equal to 0. And the second important term is range. The range is a set of all possible outputs with f of x is equal to x square. For instance, the output is always 0 or positive. So the range is y is greater than or equals to 0. Keep in mind, for something to be called a function, each value of x can only map to only y. If you plug in if a one number gives two results, it's not a function. So understanding functions is critical because they are everywhere in physics, engineering, economics, and computer science. You will see them used to model real world phenomena like growth, movement, temperature, and more. Next, let's talk about a slightly more advanced concept called function composition. Function composition is a process of applying one function to the result of another function. It's like stacking two machines on top of each other. Whatever comes out of the first function goes directly into the second one. Mathematically, this is written as f of g of x, which is as f composed with g of x inverse. This means you apply g to x, then apply f to the result. For example, we have g of x is equal to x square and f of x is equal to x plus 1. If we want g of f of x, we first compute g of x, which is x square, and then we plug into the result of f, which gives us f of x square is equal to x square plus 1. Now here is a critical detail: order matters. If we switch one order to and compute g of f of x, then we start with f of x. If we plug into g, so we first need to compute f of x. It clearly tells f of g of x is not equal to g of f of x, so order must always be critical here. First function composition is used in many areas of mathematics and computer science. For example, if you transform data by applying multiple rules, you are essentially composing functions. Let's now explore the idea of inverse functions. Inverse functions are fascinating because they essentially undo the action of a function. Here is the basic idea: if a function f takes an input a and gives you b, then the inverse function is written as f inverse, which takes b and gives you back a. It's like hitting a undo button. The notation of the f inverse is, it is important to know that the symbol f inverse is not same as minus 1 by x. It's just a symbol which to denote a inverse function. But not all inverse functions can have inverse. There are two types of functions: one function and onto functions. Only one functions can have inverses. This means that every output value that comes from one and only one input, if multiple inputs led to the same output, you can't reverse its property. Let's test this graphically using horizontal line test. If you draw a horizontal line that intersects graph more than once, the function does not have an inverse. Why does this matter? Because in real world scenarios, you often want to reverse a process. For instance, if you know the result of a temperature conversion from Celsius to Fahrenheit, you might want to convert into back. This is where inverse comes in. In summary, inverse functions are useful whenever we need to reverse or backtrack a mathematical process. Now let's see how to find the inverse of a function. It's a simple 4-step process. Replace f of x with y and swap x with y and solve for y and solve the new equation for y, this will be f inverse of x. Let's try it with an example. Suppose if we have f of x is equal to 2x plus 3, in the step 1 we replace f of y which will be y is equal to 2x plus 3, and in the step 2 we replace x with y, so y will be 2y plus 3, and if we solve for y, y is equal to x minus 3 by 2, and replace this whole equation with f inverse of x, which is then replaced by f inverse of x will be x minus 3 whole divided by 2. That's your inverse function. To check if it's correct, plug it back to the original function. If we get x again, this is a verification process. Understanding this method is crucial in algebra because in calculus. And finally, let's look at some deeper properties and relationships between functions and their inverses. The first one is inverse property. If y and g are inverses of a function, then y of g of x gives x and g of y of x gives x. This is a great test to confirm two functions are true inverses. And the second one is graph reflection. The graph of an inverse function is a mirror image of the original function across the line y is equal to x. So if you graph both f of x and f inverse of x, you should see a symmetry across the diagonal line. This try to in Demonis and any graph calculator. And the third one is domain and range. Here is a fun fact: when you find the inverse of a function, the domain and range swap. That is, the domain of f becomes the range of f inverse, and the range of f becomes the domain of f inverse. This can help you to double check if your inverse functions make sense or if you have made a mistake. All these properties are essential to understand, especially in calculus, when you are dealing with transformations, limits and derivatives of inverse functions. And finally, to wrap things up, let's summarize what we have learned. Firstly, function, a rule that assigns each input to a unique output, and compositions, applying one function to the result of another. Order matters here. And inverse functions, reverse the effect of a function but only if the function is 1 and properties, the inverse function input output base reflects across y is equal to x and swaps its domains and range. These concepts are not just for exams, they appear in real world applications like programming, physics and economics, so mastering them gives you a powerful toolset for future success. And if this video helped you to clarify these topics, don't forget to like, subscribe and share it with your friends.